Hello, so today we want to find the solutions by completing the square. So we have our quadratic equation, and what we're going to do is we are going to use a model called the area model. Now, in this situation, in order for me to solve it, the strategy I'm going to follow is I'm going to force the leading coefficient to become a perfect square. What that means is I'm going to look at the number right in front of the x squared, which happens to be -5, and I'm going to multiply my original quadratic by -5. Now, with that in mind, I know that negative and negative is positive, so this turns into 25x squared. That gives me the perfect square I was looking for. I happen to know that -5 times 50, that would be like 5 times 5 again, is a -250x. And I don't really know what 5 times 117 is, let's suppose. So I'm going to go here on my trusty calculator. I got 117 multiplied by 5. And that makes 585. So now in here I come back, and negative and negative is positive, so that's positive 585. Assuming that I'm correct, it gives me a statement, and notice how the 25x squared is already set up for me. This is my perfect square after all. I'm going to take the -250x and I'm going to divide it into two parts. So that'll be a -125x, and I'm going to repeat -125x. The extra 585 goes on the outside, so that's 585. And now I'm going to fill in the rest of the pieces. So in here, -125 divided by 5 will be a -25. If I'm correct, it tells me so. Gives me feedback. Here I repeat, -25, press enter. I'm going to multiply my two check marks. So -25 times -25, that makes a total of 625. When I press enter, notice that whatever I just added is being taken away here on the outside. And that is because this extra 625 was not part of my original equation, nor was it part of the calculation after I multiplied by the leading coefficient. Okay, so I am making sure that this equation is still balanced. I also notice that we now have here a set of parentheses. I'm going to drop the set of parentheses here, and I'm going to type what I see inside. So that is a 5x minus 25. This set of parentheses is physically on top of the square. That is my hint to suggest that this is now to the second power. And 585 take away 625. Well, I know that from 85 to 600, that is 15. Then from 600 to 25, that's 25. So I basically have 25, 30, 40. So I'm going to say that this is a -40. If I'm right, it's going to tell me so. With that, I now move on to the next step of my process. Again, remember, I'm trying to find the solutions to this quadratic equation. So now I'm going to press here, and that continues with the next step. Now in here, I now have this equation. I just made a copy of it here on the top. I see -40, so the first thing I'm going to do is I'm going to add 40 to both sides. Now 40 is going to be something that I'll need to find the prime factors for later, so I'm going to put it here. This will come in handy later. And I notice that 40 gives me 2, 2, 2, and 5. That will be used later. I've now rewritten it, 5x minus 25 in parentheses squared equals 40. It tells me to take the square root of both sides, so I'll click here. Notice how it takes square root of both sides. The effect of taking the square root of something squared is that I'm going to be left with 5x minus 25. Now here on this side, this is where these prime factors come in. I noticed that 40 was a set of 3 2's and a 5. I'm going to look at the first pair, and I'll say that makes 2. I'm going to visualize that I have a 2 and 5 left over, and I'm going to say that makes 10. As a result of this, my equation here should adjust. Now I have 5x minus 25 is either positive 2 square root of 10 or negative 2 square root of 10. This is the plus or minus effect. Here, I'll do the same step I did earlier. So now I'm going to add 25. And I'll repeat the process here. Okay. Now, with that being said, I drop down to 5x. 5x equals this and equals this as well. So this is a fraction. So I'm going to divide by 5. Notice how I have an answer at the end. I'm going to divide by 5. And now I have my equivalent answer at the end. These will now be considered my two solutions for the original quadratic equation. And that's it. This would be the full set of steps, a combination of my area model, and then solving for x. I hope this made some sense. Till next time, bye.